Hey, Math Models. I want to say that I appreciate what you guys did towards the end of last week when you jumped into distribution and combining like terms. And what I told people in class was that these subjects come up in every math class from here on out. You're going to see them. So everybody jumped in, almost everybody did the assignment last Thursday and Friday. And what I ended up with was a mixed bag of success. I had 0% correct and I had 100% correct. So this short video is meant to cover some instruction to go along with it. Those of you that wrote IDK for an answer or said, Mr. Mitchell, I need some help, you got a hold of me through a Google Classroom comment. I hear you. So this is the part where we're going to show some instruction on the topic. And I'm going to make my face go away for now. All right. We're going to use this exercise to cover a way to take notes. And let's say you got 100 the other day. You could check your Skyward to see what it is. This is still a useful exercise. These are called 2-column notes. And I want you to set up a piece of paper just like this. Now I used across the top, it's about the width of a ruler for kind of a header. And on the side, it's about the width of 2 rulers. And we have 2 columns. One column is called terms and ideas. This is like the big picture stuff down the side. And then the second column is for like details and examples. And you can do this in any class. I find this one really useful. I used to use it in college with, say, definitions. Here's the term, then the definition would follow for new vocabulary in a class. So take a minute, hit pause on your video, set yourself up a single piece of paper that looks like this. Okay. I'm assuming you're organized while you watch, and I'm going to cover distribution and combining like terms for September 28th and 29th. Okay, let's cover a concept. I'm going to cover distribution. Okay, and we're going to cover it when it's all numbers. So distribution is a multiplication tool, and it's used in all kinds of math to simplify. That's our goal here. We want to simplify. So here comes an example. 3, and we're using the asterisk for multiply here because that's how it looks in the computer. 3 multiplied times 3 plus 4. All right, these were some of the first examples in what we saw late last week. And if I wrote PEMDAS here, PEMDAS stands for parentheses, exponents, multiplication and division, addition and subtraction. It is the order of operations for mathematics. And it says with that P in the beginning, please excuse my dear Aunt Sally, take care of your parentheses first. So I had a couple students in class said, Mr. Mitchell, I can do this one in my head. I can say 3 plus 4 is 7. 7 times 3, well, that's 21. There's my answer. And that's true. 21 is the answer. But I do want to go over the technique for distribution because if I had a variable in this expression, it would be more difficult. So here is the distribution technique. Do you remember arrows from your past? If I have something outside the parentheses that will multiply by both on the inside, then I am going to draw arrows to both to remind me. I need to multiply these individually. Okay, so if I say 3 times 3 from my first arrow, well, that's 9. And 3 times 4, there is a plus sign here. So 3 times 4 is a 12, and I keep this plus, positive 12. 9 plus 12, I think about it. Sometimes I even use my fingers. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. There's 12 fingers. 21 is the answer. Same, mismo, mismo. PEMDAS would guide me to 21, and distribution takes me to 21 also. 3 times 3 is 9, 3 times 4 is 12. Put those together for 21. So this is like the longer version, but let's cover a case where it's going to be useful. So I'm going to draw a line here, and I'm going to say distribution again. And this time with variables. And variables in math expressions and equations, well, it's like X, Y, Z, etc. Okay, so this is the general case for a distribution. Let's try another one that is all letters. The variable A multiplied by B plus C. Oh my gosh. Well, I don't know what any of these letters stand for. They are numbers, I suppose. I can still simplify the math. I can draw my arrows. I can draw an arrow there, and I can draw an arrow there. Okay, so I'm going to do this piece by piece. A times B. Two variables multiplied by each other. I can say this is AB. There's an implied multiplication when you write the two letters next to each other. AB plus, this is a positive, A times C, AC. And this is as simple as we can get. This is my final answer. If I don't know what these numbers or what numbers these letters stand for, that is as simple as I can get. Out to the right, let me write A times B. That is what we did. And when you have two letters that multiply, they will simplify in math and they will write them next to each other. A times C will be AC. Okay, so let's bring this back from a general example to another distribution. And with variables, I'm going to say with a variable. And this is our example. So now I'm going to write 3, let's use a dot this time, 3 plus x. Now, PEMDAS gets me in trouble. I cannot combine these two. If I have a number or what they call a constant and a letter, this is as simple as I can get. I can't squash them together. And a lot of people have that instinct. Oh, 3 plus x is 3x. That is incorrect. I need to simplify with this multiplication. So the arrows is the habit I'm trying to get you into. This will save you when you see a distribution coming. Now let's do this same thing out to the right. 3 times 3 is the first one. 3 times 3. Maybe we remember from multiplications that that is 9. And 3 times x. 3 times x. And now you can see why they use dots when you get into algebra. 3 times x would be 3x. And here's a technique. We talked about it on Friday in third period. Sometimes I think of x as like something like an apple. 3 times an apple. If I have 3 apples, I can simplify that. 3 apples. 3 times 1 apple is 3 apples. I am going to do this distribution in series here, just like we did here. 3 times 3 is 9. And 3 times x, I have to put a plus here, is 3x. And that is as simple as I can get. It is not okay to squash these two together. If there is an x variable and I don't know what x is, this is as simple as I can get. Okay, we're doing well. I draw a line, and now I want to illustrate some of the later problems we looked at last week. We're going to combine like terms. Okay, there was a poster in the assignment Thursday and Friday. It is in this assignment also. If we're going to combine like terms, we need to follow the integer addition and subtraction rules. And I don't know why I left a space in subtraction. My brain just did that to me. We're going to follow the integer addition and subtraction rules. So here we are with an example. I'm going to say -5 plus 2 times x minus 7 plus 6x. This is called an expression in math because there's no equal sign. So we cannot solve, we cannot figure out what x is without an equal sign, but we can simplify. So I'm going to look at what is a like in this expression. I'm going to combine my like terms. And what catches my mind first usually is the numbers, just the pure numbers. I have a -5 and a -7. I'm going to use my integer rules. I'm going to combine them, which is an addition. I'm going to say -5 plus -7, and that is equal to -12. A negative plus a negative will stay negative. Negative plus a negative is a negative. -5 plus -7 is -12. And then I look at my terms that have a variable. I have a 2x plus a 6x, and that is equal to 8x. 2 plus 6 is 8. We keep the x. Here's a technique that's on the poster, and I've seen a lot of students do this. They say, okay, well, I need to find my constants. So I have 2 of those. I'm going to circle them. And then I'm just going to signal something different. I've got some variables here, so I'm going to put fluffy little clouds around them. Whatever you like to do to make them pop out at you on the paper, now you can see them separately. And I could say, okay, well, I've got -5 plus -7 is -12, and 2x plus 6x is 8x. So this is a valid answer. It's as simple as I can get if I don't know what x is. And there is a second valid answer because in math, Unlike English class, where verbs and nouns have to go in a particular order, I could write it this way. 8x minus 12 is an equivalent answer. The same. These two are the same. Okay, we're almost done. I'm going to draw another line across, and now I'm going to do both. We are going to distribute, and traditionally this happens first, then, and I'm going to shorten it from combining like terms to CLT, which is how it is in the instructions in the Google form. Distribute, and then combine your like terms. So here we go. I have the expression 2x plus, I'm going to use parentheses for multiplication this time, 5 multiplied by 3x plus 4. 2x plus 5 times 3x plus 4. Two parentheses next to each other always means multiply. Distribute first. This is my distribution, 5 times 3x plus 4. So I'm going to draw my arrows. There's one, and there's the other. And this 2x here, and if you stare at our poster long enough, you'll see an example that's very similar. The 2x stays. We need to do the multiplications first. And now I'm going to say 5 times 3x. Well, if I have 3 apples and I multiply that times 5, then I am going to have 15 apples. 5 times 3 is 15, keep the x. 5 times the number 4, now I have a constant. 5 times 4 is 20. Let's do our thing again. I have x's that are similar. And then I have a constant. I may combine these. And this was number 9 and 10 on the problem. You had a distribution first, the problems last week, distribution first, and then combining your like terms. I can put 2 apples and 15 apples together for 17 apples. And this is as simple as I may get when I don't know what X stands for. Okay. Crew, over time, you'll discover that I like to keep my notes kind of on one page. So I'm going to take an image of this and load it as kind of a key to the notes. It is 1 8.5 by 11. If you're at home, I recommend keeping these notes, keeping them in a folder or a notebook, and if and when we come back to school, bring it with you. You guys have a great start to your week, and I will talk to you soon.